Hi guys, welcome back to the channel. Hello, this is Paul again here in Maharlikans Code. And how are you guys there? And by the way, it's Happy New Year. Later tonight, in 12 midnight, we will be having some New Year celebration. So how are you guys? And I hope you enjoy, you stay happy. And despite all the challenges in life, this pandemic is still raging at the moment, and as of this recording. So right now we have some discussions, guys. We will continue on with our discussions here in Maharlikans Code. And today we will be discussing RESTful API folder structure in Golang, as I promised. Okay, so we will be dealing with the basic structure of the Golang. If you are working with a backend API like the RESTful API, so most probably you will be encountering these kind of structures. Most of the things there, the folder structures, and how you deal with RESTful APIs, whether in AWS, in GCP, or in Azure or something there, guys. So or even the on-prem API. So this is what I have experienced, and doing this practice for the API design. Okay, so we will be sharing this with you guys here, and just comment down below with your nice comment there. So we will be reading your nice comments in our sections here in Maharlikans Code. So for today, we don't forget this previous in our previous video that we're dealing with Argon2 ID. So this Argon2 ID is very important in our password, so you can take a look on my previous video, guys. So I'm sharing it with our IT Republic GitHub there, so you guys out there, you can just install it in your Golang project. Okay, so probably we will be dealing with this now, especially the API design. This is one of the most important part of engineering design, guys, in our programming. So we will be dealing with this, and I'm in the best way I can share it with you, some experience there, so we can just plainly do everything that we can, so to share the knowledge there for you guys out there. Okay, so probably yes, we will be reading only one comment in our previous discussion, guys, especially the Argon2 ID. His name is RN again. So RN, thank you so much, thanks for sharing. Okay, so we will be diving into our discussion, guys. Hello guys, welcome back to the channel. Okay, right now, guys, we are in this example, we will be dealing with rank words. This is just a demo, guys, for one of our project. So we will be testing this API later on, as this is our folder structure for a RESTful API in Golang. So most probably you are encountering this in your in one of your projects or in your work related things. You can deal with this, you probably encounter this in the future, or already encountering it. So just leave a comment down below, guys, if you want to add something into our API design here. But this is just a bare things, or the common folder structures that we need to deal with. But in every cases, in every projects, we're having different kinds of folder structures as well. But this is the most common part when you see it. So right now, in this example, we will be dealing with these rank words, and then later on we will be testing our API, testing our API using Postman, or Postman, or something that you prefer, something, guys, because this API is a RESTful API, so we have an endpoint to test. At least we can create one endpoint these rank words will calculate or count the number of words based on the most common words. It will just count. So this is one of our API for this discussion, guys. So to simplify everything. So right now the API, RESTful API in Golang, we will have this folder structure like this main .go, guys. Just leave it there first, because we just want to deal with the simplest one. So if you are dealing with the AWS or GCP or something like it, if you push it on the cloud, so you probably want to encounter this. Okay, so first of all, we can the most common part, if you are dealing with the AWS, you have a bin here, and then this one is just an example, guys. This one is, in this case, is we're dealing with AWS type. So probably like you have lib and then command cmd here, and then you have a package which is a pkg, and then in my case I always add these models to organize the Golang structs, whatever structs that you are dealing with there. So you can just put everything in the models, and then you can probably add some test data here, or you can add test, or another one is the test data here. But mostly this test is mostly if you have a TypeScript kind of thing. So this one as well, the bin and then the lib, these are all the stacks that you're putting everything here. So but in this case we are not pushing this into AWS cloud. So I just want to show you this type of structure, guys. This is one of the structure in when you are dealing with the AWS structure. So mostly you have in the root folder here, normally you have a makefile or a package that JSON or something, or the cdk.json. So if you are dealing with the AWS CDK, so the CI/CD thing, so continuous integration and deployment, something like that, guys. So if you are dealing with the automation, when you push your project to for example in GitHub, and then it will automatically build in AWS. So everything in the library here, you can define all your stacks, your pipelines, .ts, or like if you are using a TypeScript. So there is a TypeScript definitions here for your AWS accounts. So these are all the things, guys, that we need to consider, especially if you know that your platform, your cloud platform is whether the AWS or GCP or something, anywhere you push it, guys. These are the common ones. Okay, so but right now we are not dealing with these things, so we can just I just want to remove it in a moment, this lib and then the bin. I just want to show you the other things, guys. So I just want to remove this test as well. So right now make things simplify first. Now simplified things that you can add additional things here that you are common one, guys. If you are on prem, probably you have a logs here, and then especially when you are using our own package, which is the ITR logs. So you can the ITR, this folder will automatically created for you, guys, the moment that you log anything that is at least one log, like FMT or something like logging, guys. Then you can just it will automatically created for you, or you can define your own logs folder. And then what else, I can just okay, guys. So these are all the things. So okay, guys, and then we need to illustrate here. I need to these folders cmd will be you will store all these handlers or something like there is like sorry guys, we need to add one more thing. In our case, I'm adding these routers here. If you are, because we are dealing with on-prem projects, or if you have in your like for example in Linode servers, you can control everything that you have that you can install there or something like the projects. You can define all your structures, unlike those with AWS. They have their own folder structures there, so most probably we don't have much of these things, because everything the routers will be defined like in Gorilla Mux. Then all the endpoints will be found here, so you define everything in the endpoints here in these routers, and then it will be interconnected with the CMD. The CMD is like everything, all the handlers from the routers will be stored here, and then when the user invoke the endpoint like your site.com for example, and then slash version 1, and then everything that is the endpoint there, like for example the login, and then you need to create no worries guys, we will be creating later on the actual things. So I just want to overview this thing. So in the CMD you will be defining the handler here, that is the connected with the routers, your endpoint here. So you will be pointing the functions here that handles the HTTP request from your RESTful API. So everything will be defined here. You can create a new folder here, like for example like login, and then you can define for example login handler here that go, and then you can specify package the package CMD here, so something like this guys. And then you can create a function handler here, like login handler, something like this, with the HTTP request guys. So like a W, like this type. So we can all the handlers here, but we will be creating a simple API, then we can test, but not this one guys. I just want to illustrate to you. Okay, so we just want to delete this folder at the moment. Oh no, sorry. Or you can create multiple folders here guys, no worries, you can add multiple folders. It depends on your project guys. So right now we have these things, and then the logs is automatically logging here, and then the models, these are all the structs that you want to specify, like if you have a login structure or a new user structure or something like that, we will creating next time guys. So these are all the structs here, and then the projects, this one the package, sorry, this is the PKJ here, PKJ. These are all the structures here for your functions that supports from that you need to create functions from this, for example in the CMD here, all your handlers, right? You have your own common package, like you can create a utilities here, the folder. So we can create a folders here, like utils, the utils pro folder, and then you can create everything here that is like according to whatever you want, like the common functions you can create here guys. So here you can create multiple projects as well, I mean the folder structures, and then you can create additional things like environments or the converts. It's up to you guys, but this one is a customized one here. So the validations, the most important part here is the validations as well. So these are the validations. Validation, this one is for our what do you call this, the JSON schema guys. So we will be dealing with JSON schema, because in the Postman later on we will be pushing some data, post some data there. So there is a post method. We will be creating one endpoint, and then of course this routers is as I mentioned, this is the all your endpoints here, your version 1 or something like the whatever links that you're creating for your user. And then the test data here is for like any JSON files you during your testing, or XML files, you all organize in this folder. This is like if you want to transform an XML file into unmarshal that XML file into the JSON things. It depends on your requirements, like if you require a JSON format or an XML GS1 format, especially the XML one. So if you receive that kind of data, or if you require that to your users, so you will be dealing with those data. You will be storing it here, so that you will be organize those things that you can easily look for those files. So one more thing that I need to add here in our root is the what they call the schemas as well. So because we are dealing with JSON schema, so schemas, these are all the JSON formats when we require the user for the inputs, for the user's inputs. So later on, guys, I will show you this one. Okay guys, to capture our time, I'm adding this enrich all the source code here, guys, so to capture our time. By the way, these routers will be under the CMD, guys, so sorry about that. It will be under the CMD folder structure here in our RESTful API. So in this case, guys, we have a rank words here. You can collect everything, you can add multiple endpoints here. You can define as much as possible whatever it requires you to create an endpoint, so you can add here, guys. So this is the endpoint, and then under the CMD, as I mentioned earlier, that this one will be calling the handlers. So under the endpoint, it will be adding this HTTP writer and then the request. Most of the things you will be adding multiple folders, subfolders here under the CMD. So of course this one is the contents package under the CMD folder. So in this case, guys, we're adding or reading these things into our handler, which is the body here, because we're requiring a JSON format in this RESTful endpoint that we are adding. So we need to this kind of thing, guys. For example, this is our the requirements that the user might submit to when they post this data, guys, and the JSON data. So this is the JSON data structure that we require for the user to submit into our RESTful API. So in this endpoint, so we're accepting the version 1 and then the contents. So and of course with the method post. So we're using a Gorilla Mux here for our endpoint. So it's up to you if you don't use a Gorilla Mux. But the same thing is we're giving a user API users that this is the endpoint that you can try to submit this type of data, for example. So in this case, we are counting these rank words here because we are dealing with the rank words. In this case, we are developing a sample API to count those words, number of words here, like for example the quick one. So we can return back to the user that how many this type of words, how many counts there. So how many quick words that is appearing in these contents. Okay, so in this case, this is the contents that we are using under the schemas folder. So everything is here, guys. So the definition of our JSON schema. So like in our header, we require a meta, and of course the contents that we are requiring. The meta is quite standard one, guys. For example, this meta version here, we require a version here, like that. In this structure, this header is one of the requirements, is a meta, and the version. This one is we always have a version control in our API, guys, RESTful API. So in this case, if you have a version 2 in the future, then for example you can put 2 here, or whatever the API user is using, whether they are still on the version 1. Don't, so we don't want to remove those version 1 guys. So we just add a new feature, but with another version. Okay, so for example, your endpoint here is a version 1, and then the contents, and then you can create another version 2 in this case, for example guys, like version 2 or 1.0.1 for example guys. So you can add another handler here like this. So you can just point it here, then you can add another meta validation, and this one is a standard way of doing the version control guys for API. Okay, so in this case we are still in the version 1 of course. So in the future, I just want to illustrate to you how you're going to add a new version control for your RESTful API. So in this case, if I go back here again guys, in our object, this is the object type of a JSON schema. We are using the JSON schema validation guys. So later I will just explain. This is the content or the folder, the content structure of our JSON, the JSON schema. So we have a meta version here, and then the contents, as you can notice that in our sample contents.json under the test data. So we have a meta version 1, and then the contents, and then the text. Okay, so this is the contents that we are requiring, and then we refer these contents.data underscore data.json object. We just reference it because this one is another definition. So I like this type of structure guys, because you can just refer another JSON object, which is in this case contents underscore data.json. So another object here, but this one required text. You can add multiple properties here, but in this case this text that I'm mentioning, this one is a string. We defined it as a string. There's a lot of data types here, like integer, float, or something like that, or the number. You can just always refer in that JSON schema repository guys. I think it's I just want to show you. So the JSON schema, you can head over to this go JSON schema under the Shipu repository. So okay, again, I just want to show you that this is a string that we require a string inputs from the user. Okay, so it will auto validate guys, no worries. This one is a most decent validation for this JSON schema package. And then we require at least a minimum 10 characters that we are requiring from this text here. Like in this case, like if it is not less than 10, then most probably it will be blocked by the JSON schema validation guys. So it's automatically validated for you as long that you define everything in these properties here in this object. So okay, so this is the thing that, of course, this accept handler when the user will try to submit it using Postman for our testing later on guys, or actual API. Okay, so this one we will read the body, the JSON body here, of course, and then after that we will throw it to the body here, the JSON, make it as a string. This JSON schema validation will validate automatically for us guys. So like in this case, this is the function that we are using. It's under the utils and then the validation folder. Okay, so I added these things for you. You can just grab this code that I shared. Later on I will be sharing it in our GitHub repository guys. So currently there is a version 1 here. We just define it. In the future, when you're adding a version 2 or 1 point something, you can add multiple here guys, so then you can just validate automatically for you. Okay, so here the version control. Okay, so I also added extra things here, like added custom invalid errors here. So we can add the custom validation because as I mentioned, this JSON schema is not 100% JSON schema validation. You need to add your own customized error validations guys. So Like, of course, we cannot just avoid outside of this JSON validation schema. So you have your own customized validation errors. So okay, so these are all working fine. So I shared it with you, this code, guys. Okay, and then after this, this is the heavy lifting for us when we're dealing with the we're dealing with those validations from the users, because we cannot control the users the behavior when they're trying to put those things. So but we will respond back with our API that's saying that for example, that this one less than 10, so it will be automatically block for us. So okay, so later I will just show you and demonstrate it to you. Okay, then we need to parse the contents here, and then rank word. So I don't want to deal much of these things here, guys, because it's all self-explanatory maybe. Okay, so parse body here, you can just parse body and then count. These are all the rank words counting here. You can just play around later part. So I just get the top 10 most repeated words. Okay, so for this demonstration. Okay, so next will be the models here. So we have done with the CMD. So these are all the handlers here, the handler parts, guys. So if you have, like, in these contents, you require models here, like all the structs will be found here, or you can create a folder or something. But for me, I just added the contents that go or something so straightforward, because I want to add retain here. You can add a different folder, or you can create a single file with as long that your data model is here, guys. So all the structs will be residing in this models folder. And of course, this JSON schema, these are the all JSON here, the all that JSON. So that means okay, you can define everything here, guys, in your schemas here. This is the all folder. So all this contents here, all the objects, you need to register it here, guys, under the one-off. This is one of the requirements in JSON schema, Go JSON schema repository. So everything we need to add here, register everything here, guys. And then these are all the contents I specify, and then the version here, these are all the things, guys. And then you have your test data. Of course, the test data will be the result of your whatever the data that you are playing around with your testing or something, or your XML file, or you're accepting GS1 XML file, or the JSON format kind of thing. It's up to you, guys. It's up to your own what do you call this, the RESTful API. So everything that the test data from the users data, or you want to integrate something from the XML file, you need to put everything organized here. You can create the folders here, everything, guys, for your testing. Everything will be here, all the related data, either XML or JSON file. And of course, your utils, these are all the common functions that you are using in your RESTful API. For example, in the set environments here, you can set multiple the ports or something. You can define it here, guys, for example. And then the converts here, response. This converts JSON schema is you need to define as JSON. I need to define as a byte, guys. So in this case, I just want to run this one. I think I already prepared it. So in this case, for example, this one, guys, I want to run this because this JSON schema, it requires a byte, guys. In this case, the contents of this one, for example, whatever the contents here, will be translated into a byte. Okay, so in this test, so you need to copy that one. First, start from here and then up to here. You can copy this and then paste it in your schema here. So this schema is requiring a bytes. So whatever, for example, these contents, you have a constant here, and then whatever the contents here, it will be converted into bytes. Later it will be called into this part, for example, the JSON schema, the schemas, and then the contents. As I mentioned here, it will be using these contents here, this JSON content. So whatever the contents here, will be reading that from the JSON schema. It requires a byte, guys, so you need to define everything here as well. So you can grab this code, no worries. Again, the source code will be available in our IT Republic GitHub. Okay, so this thing we are now, so you can test this, you can change this in our testing. So you can just copy whatever you are defining or working on, the schema here, the JSON schema, the object will be translated into a byte. Okay, so after that, where we are now, I think we have done this part. So this is the main thing for the JSON schema. So whatever the thing here, and then also the response I'm giving you as well, this one, guys, for the HTTP response. And these are all the most common parts when we return a JSON schema from our RESTful API. Whether this one is you want to store, this function will store into the user's browser, like for example, you want to return without the caching. I mean with caching, guys, with caching. This one is without caching, no cache here. So I just cache with no store or something like that from the header. So you can set the header here. And then this one mainly for result that you want to store it at the moment in the user's browsers there. So they will be stored at the moment, but this one is no caching, guys, from the user's side when they access the endpoints, or you already have the website, and that's it. And I'm giving you also this one, and then the validation here for our JSON schema. And then I think that's it, guys. It's time to run this endpoint here. Okay, so I just want to run these things here. So I just want to clear. I want to run our API now for the first time. So we want to test and see that our API will be returning something or not. So based on our definition here, guys, remember everything you define here, like the minimum length, we can test this, or is a string or something, and then additional properties, we set it as false. Because if you want to add, for example, here the contents, and then you add additional properties here, like for example, you want to add the image or something like this, this one will be like it will be blocked as well, guys. So we will test this in our API. So now our web server is running under this main.go here for our testing purpose. So we have our own listen and serve here under the port 8080. Okay, so we will copy this, and then we will be heading over to our rank words here. Just want to close this part. So this is our endpoint now. So if you want, if the user wants to test using the endpoint, so we will be executing this one, guys. So as you can see that it returns the most common words, and then the status is 200, which is the OK. And then the headers here, we just use the HTTP response without the no cache or something. So our JSON API returns successfully, guys, like the specific words, the top 10 only. So for example, in this case, the word "the" is count 28 times it appears in these contents. You want to validate the things, guys. For example, this one, the versioning, we only set the version 1, but we don't have the version 11 here. So we want to test it again. So the JSON schema will be validating automatically for us, like the version. This one is our by the way, this is our custom validation here, guys. So I just added this one. Okay, so like in this case, I'm adding additional image here, the property, which is I set the additional property here, for example, okay, this one, So the additional properties, we set it to false. Otherwise, if you set it to true, you allow the user to add um, beyond your configuration here, guys. So like in this case, for example, the image with which we are not requiring from the user's input, and we are not requiring as well in our RESTful API. So it will not be, it will be accepting. So it's up to you guys, but by default this additional properties is not there, so you just add it here. Okay, so don't forget this one is one of the important things there. So in this case, I'm adding the image, which is the default there is false. So automatically the JSON schema will be validating for us. So it will throw back the additional properties image is not allowed. So that means you need to remove this when the user's behavior tries to make a funny things there, guys, in our endpoint. So we just want to add additional things we are validating, guys, based on our inputs. Is this I just want to remove this. Okay, so based on our definition here in our property under this text, we have the minimum length of 10. So for example, this one is the characters here is not even 10, so it's less than 10. So we just, if the user tries to submit it, so the JSON schema validation will automatically throw an error for us, guys. So we are not, this is the beauty of this JSON schema validation, this part. I just want to show you this part, because it automatically block for us whatever the is not defined in our properties here. So these things, strings length must be greater than or equal to 10. So if I put back the thing, so and then run it again, then we don't have the error validation now, guys. So everything is passed. So the words here, these are all the things that we return from our RESTful API. So this is our first ever RESTful API that we are dealing with in the here in Maharlikans code. So thank you so much, guys. I think that's it. We are demonstrating to you how to create a simple RESTful API in our Go project. So if you are a backend engineer, backend software engineer, so you will be facing this, probably you're facing these codes here or something like this. So you need to deal with JSON or GS1 XML files. So probably this is the things, guys. So this is a big help for us, and then you can do the rest of your validations as I've added here in our custom validations there. So thank you so much, guys, for watching. And one more thing that I'm adding, this what you call the Swagger. You can use this Swagger for API documentation or design or development. You can validate most of the things. You can play around with this one, guys. I think it's a free one. Then there's also a free premium package for this. It will automatically create an API documentation for you, like based on this design here. Whatever you define in your JSON schema, it will automatically created documentation for you. But for me, guys, also here in Postman, you can also under these APIs, whatever you define in your collections, it will be created automatically for you, guys. So those documentation. But for me, I prefer human things, like humanly created documentation, guys. So it will be very important because you can explain further and then put some examples there. But also in the Swagger, they are doing the best things that we can automate based on your JSON schemas. So that is the thing, guys. You can save a lot of tons of your time creating API documentation. Okay, and also these IT Republic rank words, I also publish it in our IT Republic GitHub, so you can just grab the source code of this, and then you can play around with your local development. Okay, And then we have successfully tested, and I think that's it, guys, and thank you so much for watching here in Maharlikans Code. Hi guys, thank you so much for watching here in Maharlikans Code, and I hope I impart with you some knowledge and experience as a Golang developer, guys. So hope you enjoy watching and discussing with you guys here in Maharlikans Code. So you can grab these rank words that as on our example for our IT GitHub, IT Republic GitHub there. So you can just grab a copy of that for the API design and all the source code as well. So you can just take a look and review in our in here in Maharlikans Codes what we are discussing here. So probably in our next discussion, guys, I'm still thinking of it whether I'm dealing with right now I'm working on one open source project, probably for our what do you call this, maybe when we save storage, or I mean something like we need to save a file for local storage. So everything that we need to use that one, so we can that is one of our project that I'm thinking, guys, for our next discussions here in Maharlikans Code. And that is one of that thing, or maybe the next one probably a secret manager for our whatever that this one is already exists in AWS and in Google and in and also in GCP. So they call it the secret manager. So I'm thinking of it that we can use in our project as well. So because that one is we are paying for that one. So although it's a cheaper one, but maybe we can use it. We can create in our one of our project, most especially when you're dealing with on-prem projects, like localized project, like installed over the network in your internal organizations there, the network. We can use that one instead of storing the plain password. Put it on your, or the secret keys or something like API keys in your source code. So we will store it in a secret manager, something like that, guys. So we can probably design that in the simplest way. At least we can use it in our Golang project. So stay tuned for that, guys. So that is one of the thing that I am thinking right now, or the local storage as well. So because this one is all interconnected, most especially when we store like for example the secret manager or the keys, but we need to store it on a certain file in our project, like the way that we are storing ITR logs, and then after that we can store the values there, but it's all encrypted. So and then for our persistent usage in the later part, so because normally we will store those values in a Golang map, so especially in the memory. So we will store it there, but when the memory or one of your machine restarted, then all the stored in the memory will be gone. But we need to make it persistent. It means that we will store it in somewhere else. But right now I'm thinking as well that we can create file storage, or maybe a single file storage, or like that. We can grab all those data that we stored in the memory and then restore it back to our memory again into our Golang map. So that is what I'm thinking right now. Maybe the two projects that is I think it's useful in our Golang project. So stay tuned for that, guys, and thank you for watching here in Maharlikans Code. See you again in our next episode here in Maharlikans Code, and you can support me, guys, if you want, by subscribing to my channel. And thank you so much, and may God bless us all. Thank you, and bye bye. Keep safe, everyone.